So how do we get insulin resistance of the brain? Here we have the glucose in the bloodstream that is to feed the blood vessels of the brain through the blood-brain barrier. And we have these one-way valve receptors that take glucose out of the bloodstream and therefore can be used for energy. This is the same for insulin. And what can happen is at these receptors, they can become resistant, and certainly when there's a lot of insulin around. This then creates a problem because we have glucose that is able to get into the brain, but then insulin finds it harder and harder to get in. This creates what is known as the blood-brain paradox, which is as we get increases in blood glucose, we then get increases in high brain glucose. But with insulin, we have this high blood insulin, but because it finds it harder and harder to get in because the receptors have become resistant, we then get a lowering of brain insulin. This causes a condition called cerebral glucose hypometabolism, which means that it's sluggish in terms of the brain's glucose processing. And this is an energy crisis for the brain. This is one of the driving forces behind Alzheimer's disease. And this is not association, this is causal. Alzheimer's is a neurodegenerative disease, which is just a fancy word for the brain is dying. The brain is literally swimming in a pool of glucose, but it's starving to death, and it can't use that glucose to maximum effect.